Alright, we're going to take a look at lesson 4-7, so the real number system. Let's start with this quick review here in the corner. So this says write the following numbers as fractions in simplest form. So they want it to be in a fraction. So 4.5, to me that already looks simplified, but I suppose in this case they're probably wanting this to be an improper fraction. So let's go ahead and do that here. So if we're going to do 4.5, I'm going to just use this space here. So we're going to use 4.5. We need to put this into an improper fraction, so we do 2 times 4 plus 1. So 2 times 4, what's that? 8 plus 1 is 9, so 9 over 2. So I'm going to write that over here, 9 over 2. What's next? 0.15. Okay, 0.15. So 0.15. Sorry, I suppose I should have put an equal sign here. So 0.15. What about for this one? I'm thinking easiest way for me to do this is the 1 is in the tenths place, the 5 is in the hundredths. So couldn't we write this as 15 over 100? Now, aren't those both divisible by 5? So we could do 15. 15 divided by 5 is 3. 100 divided by 5 is 20. So you'd say 3 over 20, right? So I think here we could do 3 over 20. The last one is the square root of 25. So square root of 25, to me that looks like it's simplified, okay, hold on. Square root of 25. You can plug that into your calculator since we already know how to do the square root. So when you plug that in, square root of 25, we're saying what times what gives you 25? Pretty sure that's 5. To me, that looks as simplified as it can get. However, since it says fraction, I guess we'll write this as a fraction. 5 would be the same as like 5 over 1, right? So I'm going to write that there, 5 over 1. Okay, next. This says here you have learned that rational numbers like these are numbers that can be written as fractions. Irrational numbers are numbers like pi and the square root of 15. These are numbers that cannot be written as fractions. Do you remember what the number for pi is? If you plug that into your calculator, it goes on until it hits the end of the screen. So this one is one that does not repeat and it does not end. So it says cannot be written as fractions. Oh, sorry, didn't mean to cross that out. Cannot be written as fractions. That should also say it's a decimal that does not repeat and does not terminate. So I'm gonna jot that right here. Decimal that does not repeat or terminate. So what we're saying here, again, those are irrational numbers. That's what we're saying here. Irrational numbers, decimal that does not repeat or end. So let's plug these numbers in our number bank into this Venn diagram and see what we can categorize. So it says label the diagram with the terms whole, integer, rational, and irrational. Then complete the diagram using the numbers from the number bank. Okay. Well, they just told us pi and the square root of 15 are irrational, so let's put that on this line. I'm going to type it because I'm worried I don't have enough space. So what if I type it right here? I'm going to say these are irrational. Well, if all of these are irrational, that must mean that this side is rational. Okay. And let's be more specific. So we've already used, I'm going to cross these out here since we've already used some of these. We've already used irrational and rational. We have whole and integer. Do you guys remember what those are? So we have natural numbers and then we've got two others here. And they're all under this big umbrella of rational numbers. So this next one, this is going to be our whole numbers. So I'm going to jot that here. Whole. And then this spot right here, I'm going to type integer. So let's remind ourselves here. Let's see. Natural numbers were ones that you could count on your fingers, or any solid whole number here. I guess whole number is a whole nother one. Okay. Natural numbers are ones that go from 1 up with no decimals. So 1, 2, 3, 4, 5, and so on. So in this space here, let's write another example of this. So what from here do we have as an example? Hey, I see the number 1. Let's write that. 1. Kind of large. That's okay. Okay, since we use that, I'm going to cross it out over here. What else do we have? Whole numbers. Whole numbers are all of those, 1, 2, 3, 4, 5, and so on, and 0. Integers are all of those, but they also include negatives. Do you see anything else from our number bank that we could include in this spot? That's an integer, non-decimal, but it could be negative. I see negative 1. I think that's it. I'm going to cross that out and put it here. What else we got? Now we need some rational numbers. Rational can be put into a decimal. Into a fraction. So rational numbers can be put into a fraction. Which of these can be put into a fraction? Well, 1 2/3 is certainly a fraction. 1 2/3. What else we got? 0.8. Can't that be put into a fraction? Because 0.8 should be 4/5. So 0.8. And how about 2.2 repeating? I think that could go here. 2.2 repeating. Next we could do, that must mean the square root of 7 goes over here. Can you plug that into your calculator really quick? Square root of 7. Square root of 7. Holy moly. I'm getting 2.64575 stuff. So that does not end and it does not repeat. So therefore it is irrational. I like to think of this as like, do you ever have like an irrational friend that just goes on and on and on and on and on, and they don't repeat and they don't stop? So this you could think of irrational the same way. It goes on and on and on and it doesn't end, it does not repeat. Rational, there's an end, you can put them as fractions. Okay, let's do this part here on Meteorologist. It says they use this formula, t² equals d⁻³ over 216. So our job here, write and solve an equation to determine how long the thunderstorm will last if it is 6 miles across. T represents hours, D represents miles across. So I suppose we put a 6 here. So for the equation, what should we write here? Shouldn't we do, I'm going to zoom in just a smidge so I can write a little more easily. So I'm thinking what I'm going to do is I'm going to put t² equals, and then I'm going to write, we have 6 miles across, so 6⁻³ over 216. Sorry, that's bad handwriting. T² equals 6⁻³ over 216. So let's see if I can do better here. 6⁻³ power. There. I can do a lot better when I can write big. Okay, so if I'm going to simplify that, I'm going to plug into my calculator 6⁻³ power. 6, and then do this caret 3. So if we do 6⁻³ power, I get 216 over 216. So I'm looking at t² equals 216 over 216. And that equals 1. So really, I'm going to change colors one more time. t² equals 1. If we need to get 1 on a side by, t on a side by itself, do you see how it's squared? What's the opposite of squaring something? The opposite of squaring, isn't that square root? So we're going to take the square root of each side. When you do that, it cancels out the 2, so we're saying the square root of 1 is t. So we're going to say t equals, what is the square root of 1? What times what gives us 1? Isn't that just 1? So we could say here, this should last, it was asking how long it would last. We actually know that this is positive or negative, but does it make sense for it to be a negative hour? I don't think so. So we're going to keep it as positive, so we're going to say this might take 1 hour for the storm to pass. Let's do the next one. So this one's asking us here 12 miles across. How long will it be? And it says round to the nearest whole number. So I'm going to record this equation again, but this time we're plugging in 12 for D. So I'm going to record t² equals 12⁻³. Well, let's supposed to be an exponent. 12 to the third over 216. So let's switch colors here. T squared equals, what is 12 to the third? So we're going to say 12 to the third power. I have 1,728 over 216. Sorry, it's supposed to be a 6. So we've got t squared equals this. So I'm going to take that, simplify that side, and I get 8. So I'm looking at t squared equals 8. So now we need to undo the square root. Sorry, undo the square. So to undo the square here, let's do square root of this side, square root of this side. When we do that, we've just canceled out the square and the square root. Those cancel each other out. So then we end up with t equals, what is the square root? Square root of 8 is 2.828 stuff. Oh, I guess I'm going to move me. But it said round to the nearest whole number, right? So I suppose we could say t equals about 3 hours. Again, it doesn't make sense for it to be negative. This could potentially be plus or minus, but I've never heard of negative 3 hours thunderstorm. So I suppose we could say that it's a plus or minus, but then we end up with a positive 3 hours. Okay. Let's see what we can do on the next page. This is saying circle the correct phrase to complete each sentence and explain your reasoning. So this is saying 0.67 is which one compared to 0.67? 0.67 repeating. Oh, I see. So let me think here. Wouldn't this be the same as saying 0.67777 forever? And this one is just 0.67. And I suppose if we wanted to, there's nothing after it. But if we wanted to, we could plug a 0 in, right? So now let's think. We are now comparing. I see that the 10th place is the same. There's a 6 in each, right? The 100th place is the same. Now, what about the 1000th place? The 1000th place. So we are comparing a 7 and a 0. Which one is bigger? A 7 or a 0? 7, right? So we would say definitely greater than. And when it says explain your reasoning, I'm going to say, well, because 7 is greater. Oh, those kind of look the same. 7 is greater than 0. That's my reasoning. What's next? The square root of 33. Okay. I don't think we're going to get through all this in the next 2 minutes, so why don't you try these problems, 2, 3, 4, and then we're going to go through that as well as this last part together on the next video, okay? So you attempt these. When you're done, click play on the next video.